Very good morning, one and all. So, welcome you all for the third day of Faculty Development Program on Gen AI. So, today with us, we are having Dr. Wilson Amalraj sir, Principal Engineer, Verizon Data Services, India. So, I'm very happy to introduce about him. So, he has completed his bachelor's degree in Madras Institute of Technology during the year 2010. After that, he completed his MSc in 2012 from National University of Singapore, and he received his doctoral degree from National University of Singapore during 2016. He is a senior research scientist experienced in building products and POC based on computer vision as well as robotics. Computer vision has been a part of his life for the past 12 years. He has worked on end-to-end pipeline with right from data collection, data annotation, training, as well as pruning various machine learning models for computer vision. So currently his focus on Gen AI based solutions. So with this short introduction, I welcome you, sir. Hand over the session to you.
Okay, sir. Okay. Check. Okay. Okay. Thanks, Doctor, for the introduction, kind introduction. Okay. So today we are going to talk about generative AI for everyday use. I mean, like we all talk about generative AI. So, but I'm going to go in detail on how to use for our day-to-day usage. So that is what I'm going to focus on. So I'm going to split the session into two. The first part I'm going to cover the basics of generative AI. Online. So the first part I'm going to just give an introduction on how to use this. Then the second part I will give a hands-on on how to code or how to program this particular whatever the models that we have. So there are many generative AI models available, and every day there are new models coming out. But we have to be selective in using what models that we are going to use. Okay. So this is my introduction. So Dr. Guru already covered my introduction, so I don't have to go in detail. Okay. So then my education background. So then skills and expertise. Maybe this part I will touch a little bit. Okay. So most of my work experience is on computer vision. So until generative AI came or ChatGPT was introduced, so this boundary between natural language processing and computer vision was very clear. So you don't enter natural language processing or you don't enter computer vision. So that is how it was. Okay, but once this ChatGPT came, there is no clear boundary. So now there is no more computer vision or natural language processing. Everybody is a AI machine learning engineer. Okay, so but when this generative AI models were introduced initially, so all the applications were on text based applications. So you have to use semantic search, or you have to use natural like entity recognition, or you have to summarize the text. So those were the applications that we were initially building until this vision LLMs came into picture. So after this onset of vision LLMs, now people are looking at multimodal LLMs. So multimodal is nothing but you can do computer vision as well as text. So that is the concept here. So now since my background is on computer vision, I can go back to working on vision LLMs. But during this transition period, I moved to natural language processing. So now my expertise lies on computer vision as well as natural language processing. Now all of us build generative AI based solutions. So this is how the industry is. So now traditional computer vision based industries are very limited. இதில் தான் வந்து யூடியூப் வரும் அப்படி சொன்னாங்க. க்ளோஸில் வரணுமா? ஓகே, கேட்கலையா? இது பெட்டரா? ஓகே. अच्छा Okay. Okay. Okay, sorry. So I will continue now. Okay, so now the volume is better. Do we have the echo? Okay, continue, madam. Okay. So as I was continuing, so now the boundary between computer vision, natural language processing is all gone. So everybody is a machine learning engineer. So you have to be knowing computer vision as well as natural language processing to survive in the industry now. So this is how the market is. Okay. So traditional computer vision based industries are very limited. So there are a few companies though which do classical computer vision based solutions, but they are very limited. So most of the applications that we see in the industry, especially in the enterprise setting, are multimodal. So you have to know natural language processing plus computer vision. So this is how it is. So today I will cover a little bit of computer vision and natural language processing. So this is how I am going to structure. Okay. So this robotics is what I did during my PhD. So I worked on unmanned ground vehicles, unmanned aerial vehicles, so mapping and localization, autonomous control. So these are the areas that I focused on during my PhD. But frankly speaking, robotics now, especially I worked in both Singapore as well as in India. So the reception towards robotics is very limited. I mean, because of the hardware limitation. So you have to invest heavily on the hardware. So once you have the hardware, next comes the algorithm part. So choosing a field in robotics is, I would say, is a bit risky. So you can do for your personal, I mean, like knowledge or something. But once you move on to the field of robotics, it is going to be very difficult to survive. So this is how the industry is. Okay. Okay, this is my brief employment history. So I worked as an instructor for a year in National University of Singapore. So where I was teaching students on building like electric car or multi-rotor platform. So those were the key projects that we did during that time. So we did a lot of practical based learning. So we learned how to launch a satellite and how to stream data from a satellite to a ground station seamlessly using just an Arduino. So you don't have to have like a fancy hardware. So but you can just use an Arduino and an interrupt to send and receive data packets from a very high flying object. So we simulated using an aerial balloon. So we flew it for a very high altitude, then we transmitted data. So this is how the students were tested. So while while I was working as an instructor. So then I moved on to industry. So once 1 year after I was an instructor, I moved on to industry. So I first worked in Hangar of the Future, Airbus. So there mainly they were looking at how to improve the hangar operations. So that is why like I was recruited, and few other teams were recruited. So we built a proof of concept in 1 year for the Hangar of Future, but it did not take off. So we all moved on from Airbus. So after that I worked in a startup. So this is where I built an end-to-end deep learning product. So it is a security solution, computer vision based. So you can use just your regular IP camera. Then you can recognize number plates, then provide access to particular vehicle that is entering the premise. So we deployed it in few of the schools in Singapore. This is mainly for attendance tracking. So when the vehicle comes in, we automatically log in saying that okay, this person has entered the premise. So then we will the management will do the further things. So some of the solutions, I mean, like, so here we tried on different edge deployments because the product has to be deployed on premise. So you cannot have a cloud server, or you cannot have the data streamed to a cloud server. So we deployed the entire product as a single end-to-end pipeline on the premise. So for this we had to test a lot of edge devices. So we were looking at NVIDIA devices. So at that time a lot of Jetson based devices were coming up. So Jetson Xavier, Jetson Orin. So all these were slowly coming up. So we had tested all of the Jetson products, and we, for the cost factor, we choose Jetson Xavier. So we will deploy our model optimized to run on a Jetson Xavier, and the latency has to be 100 milliseconds. So when the car is entering the field of view, which means the camera's field of view, so you have only 100 milliseconds to recognize the plate and provide the correct number plate. So this is how we did the solution. So this was successfully deployed. Then I moved on to NCS. So NCS is more like a consulting company where they do a lot of consultations for telecom providers. So Singtel is similar to Airtel in Singapore. So we worked on a lot of use cases. So we worked on elderly care, we worked on quadruped robots to do autonomous survey. So then after a few years I moved on to generative AI. So there I was fine tuning a lot of open source models. So Llama, then XGen, all these models we will take the base model, we will take our internal data and make it or curate it to train or fine tune the base model into an instruct model. So this was my major work, because while I was a research scientist there, I worked on optimization of the models. So I know how to serve the models using Triton. So this is something that will give you like a step forward when you go to the industry. So this NVIDIA, they have different serving mechanisms similar to PyTorch, similar to TensorFlow. So they have their own serving mechanism called Triton serving. So there you can accelerate a machine learning model. So when you are talking about research, so you can have your own data set, you can build your model, you can get very high results. But the moment you talk about deployment, you are constrained by the resources available. So this is the truth. So we try to accelerate our models, whatever they may be. So whatever we train, so first instance we choose the architecture. So that is how we do. So when we are looking at the end-to-end pipeline, the first step that we will look at is the architecture of the model. So this model has to be quite fast. It cannot be slow. So the slower models with very high, even with very high accuracy, they don't survive or they get overlooked by the smaller models which have decent accuracy. So then comes the serving mechanism. So serving mechanism is how you consume the model. So when you have a research prototype or you have a model, so you have to serve this for an end user to consume. So this we generally use Triton based serving or PyTorch based serving or TensorFlow based serving. So depending on how your structure is, you can choose. So but since NCS was heavily invested on NVIDIA, and NVIDIA was out of the way. I mean, like whenever we had a problem, they would send down their people directly and they would sit with us to find out what is the exact problem and how to solve it. So they were actually quite good at helping people deploy all these models in their environment. So we obviously had chosen NVIDIA's platform, and we did a lot of MVPs using NVIDIA edge devices. So then we have DeepStream. DeepStream is one of their accelerating platforms for computer vision. So let's say you have an edge device like Jetson Xavier. So it usually supports 2 IP cameras. So with a real-time inference speed of 100 milliseconds or whatever. So you can run your model and get your inference done within 100 milliseconds if you optimize properly. But when you are using DeepStream to accelerate, you can connect up to 19 cameras. So this brings down the cost of your deployment. So that is what industry mainly will focus on. So they will not focus on how good your model is. Of course, you have to reach a certain level of accuracy, but they will mainly look at how much you reduce the cost of the infrastructure that you are going to deploy. So one of the projects that we were doing while at NCS was we deployed bed exit prediction at Changi General Hospital. So we will have a camera focused on the bed, and when the patient is trying to get up from the bed, we will send an alarm to the nurse. because these patients are very elder, I mean like very old, and there is a very high risk of them falling down when they come out of their bed. So this was the reason why the hospital wanted this bed exit prediction. So we built a model based on body postnet. NVIDIA also has their own post recognition algorithm. So then when we started to deploy, we cannot have one edge device for each of the bed. So let's say there are 100 beds, so you have 100 edge devices. So one edge device would cost around 800 Singapore dollars. So now you talk about the infrastructure cost. So 800 into 100. So that much you have to invest. So it is a very I mean like cost intensive project. But when you start using DeepStream, you can connect 19 cameras to one edge device. So this we are talking about Jetson Xavier. So when you go for a bigger platform like Jetson Orin, it is a bit more expensive, $1,500 I think. But you can connect more cameras, several cameras, more than 40 cameras you can connect. So this will let us bring down the cost. But entry into DeepStream is a bit difficult. So that is why, I mean like initially people don't adopt DeepStream. But once you know how DeepStream works and how you can connect your cameras and do inferencing based on the model serving, it gives you an edge over rest of the people in the industry. So even in industry, people struggle to use DeepStream. But DeepStream is one of the most sought after technology. So then after working in Singapore, I moved back to India. So now I work as a principal engineer for Verizon Data Services. So here we mainly focus on GenAI based applications. So now as I had told you previously, right? So computer vision had been merged with natural language processing. So now whatever we do is natural language processing plus computer vision. So everything is merged together. So Verizon being a big telecom provider, similar to Airtel or BSNL. So they are one private entity in USA. So they are providing phone services, internet services, all these technologies in US region. So they have around 1000 plus employees in their own company, where they are dealing with different segments of their, I mean like day-to-day application. So in their day-to-day application, there are a lot of requests. Okay, let's say for example, you have a ticket raising platform. So where a consumer comes in, consumer is the person, let's say I am using an Airtel service. So I will, if I have a problem, I will go to their website and launch a complaint saying that, okay, so this router is not working. This particular thing is not working, something like that. So once that thing is entered, it has to land in that particular, I mean like the person who is expert in dealing with those problems. So since this team is very big, it is very difficult to identify before going 4 or 5 rounds, finding the right person to solve the problem. So this is how it is. So we came up with a GenAI based solution. So when the customer enters the problem, so he can be more descriptive, or he can just say it in 1 or 2 words, the problem that he is facing. So whatever the problem comes, then we will look at the text, understand the intention of the problem or the semantics. Then we will deploy a GenAI based ticket routing system. So this will go and reach the person who is an expert within 1 or 2 bounces. So earlier it used to be 6 or 7 bounces. Now we had reduced to 1 or 2 bounces. So this was very, I mean like early product which I had done for Verizon. So then we have a lot of data processing based applications. So now when you talk about generative AI, RAG is a very common topic. RAG is retrieval augment generation. Okay, retrieval is you have a set of data in your database. Once you have a query, you extract all the records, then you augment with an LLM, then you generate the response. So this is retrieval augmented generation. This is a very common problem in all of the industries, and some of the startups, they just provide this RAG as a solution, and then they launch their own generative AI product. Okay, so this is how the industry is now, but it is not a simple problem to solve. So when you are looking at text based extraction, you can have different formats of data. You can have PDF, you can have PPT, you can have docx, you can just have plain text, you can have HTML, Then you can have XML, UML, all these format of data is there. So the data pipeline, it has to ingest all this information and it has to extract relevant data and put it in a vector store. So this is one of the key problem that the industry is lacking, especially when we are looking at tabular data. So let's say you have a PDF document and you have a table which expands to 3 or 4 pages. Only in the first page you will have the column header. In the second page and the third page, you will not have any information about the table, but just the data. So as a human, when we are looking continuously at the table, we know where to associate the information. So we know where to look for the column header, we know how to look for the row header and how to associate different columns. As a human, we are able to do it. But when we are talking about generative AI solutions, we have to extract the information and feed it to generative AI. So this part, if it is not done properly, then the model, however good it is, it will not be able to give you the best response. So this is one key research area where actively people are looking at. So this people have not solved it and they are trying to find a workaround to solve this. So this is why we do a semantic based grouping. So I will explain in detail how this works. Okay, so let's say you have a PDF document. Okay, so you have an ingestion pipeline. So you read the PDF document, extract the text. So text, images, tables, all of these you extract. Okay, then you put it inside the vector store. Vector store is similar to databases. Now all the SQL databases like Postgres and MySQL, all these have vector supports. Okay, vector, what I mean is you extract the text based on the LLM that you are going to use. You convert this text into a numerical representation, which is a vector representation. So let's say you use a sentence transformer to get this text into a numerical representation. So the understanding is, let's say there is a sentence like there is a cat and I am growing lots of cats. So these are two separate sentences. But once you do an embedding, which means you convert this text into a mathematical or numerical representation, these both sentences lie together in the vector space. So this is the first initial transformation that we will do. And all these vectors we will put it inside a vector store. So that is why they are called vector stores. And there are a lot of companies in the world. So like Milvus, Elasticsearch, Postgres, Redis, all these are vector stores which only do data ingestion. So you take in all the vectors and how fast you can retrieve back the vectors and give it back to the customer. So they all these products, they focus on this particular problem. Okay, so let's say you have an X vector store. So you have used an sentence piece transformer to convert your text, all your text into an embedding, and you have stored in your vector store. Okay, now you have a query, a question like what is my food today, something like that. So or what is my revenue for this particular year. So let's say it's an enterprise company. So this will extract all the vectors corresponding to the question that we are asking. So for this they will do semantic matching. So they will understand this question. So they will convert this question into a vector. So then they will look for similar embeddings or similar vectors in the vector space and they will retrieve all the vectors. So they will give you all the vectors from the vector store which is related to this particular query. So then you have a re-ranking mechanism to rank all these return responses based on 1, 2, 3, 4, and then you send all these things to the LLM as a context, saying okay, so this is the context and this is the query. Now you take this context and you give me an answer, then the LLM is able to respond. Okay, why this problem came is because you cannot feed an LLM infinite context. So the context window for an LLM is limited. So initially when they launched, the context window was 2048 bytes. So that is how it was. Now they can accept 1 million context length. So that is how they claim. But most of these are paid models. But when you are talking about a context window, you cannot fit an entire book into an LLM's context window. So you have to split it into pages. And this is where the retrieval part comes. So once the query comes, you retrieve only the relevant information from the vector store and pass it as context instead of sending the entire information to LLM. So this is the technology. Okay, this is what mainly people are working on to provide a solution, and this is not a finished solution. People are still actively researching to find out better ways to ingest data and retrieve data and serve the response. Okay, so some background. Okay, so let us go to the basics of what we are going to cover now. So now I am going to just give you some information on how to use this, whatever I talked about, right? It is not only for an industry. So this generative AI model is a human language understanding model. So earlier when we are talking before generative AI came in, so when we are feeding this query or the question to the model, it has to be somewhat limited. So you can only do it in the way that the machine learning model can understand. So you can only feed in data points, some numerical data. You cannot convert, you cannot pass in a direct question or text to an LLM or any machine learning model per se. Okay, so but when the generative AI came in, so this was a revolutionary thing. So that is why it is very revolutionary thing. So it is able to create new content. So earlier we have to teach the model what it is supposed to do. So let's say it is a computer vision model, you have to train it to recognize certain things. So and it will only do that particular thing. So out of the training, if you go, it will not work. So that is how the field was. But when this generative AI model came in, so it can do a lot of other things which we have not thought. So it can generate text, it can generate video, it can generate images, it can even code. So these are the new emerging patterns that came out because we are using generative AI. Okay, so yeah, so unlike traditional AI which just focus on analyzing data or classifying data, so now you are using an LLM to produce original content. So the content which was never present in the world. So this LLM, they have that the knowledge to create new and new piece of information. So this was very revolutionary. So this is why people moved from classical computer vision or classical natural language processing to generative AI. So when we are looking at generative AI based models, right? So underlying mechanism is transformer based architecture. So this let's say this LLM or generative AI field blew up in the year 2021. Okay, so that is when people started using generative AI or adopting generative AI. Even before that, in the 2017 or even before that, in the 2015 or something, Google and several other researchers, they have created this transformer architecture. So this transformer architecture is not something new. This attention based mechanisms are new. But when you pass like very huge amount of data to as training to these LLMs, certain behaviors emerge out of these LLMs. So that is what people found out. So this is why we gave a new term to these models. So the training or the supervised learning is nothing different, except that you pass billions of data. Earlier you would feed like 100k or maximum 10k to train your model. Beyond that, if you pass, the model will not work. So it will not converge. So you have to be very careful in your data preparation. But now for the generative AI models, you pass in like any amount of data, billion amount of data you pass, and you let it train for months altogether, 6 months or 8 months, you let it train. And after that, after quite some time, some behaviors emerge from these models. So those are called emergent behaviors. So only those models which have these emergent behaviors are called generative AI models or LLMs. So rest of them, we don't call them as LLM. So even BERT, it is using an bidirectional autoencoder. We will not call it as an LLM. It is still an encoder based architecture, that's all. So but you take in Meta's Llama models, all these are even 7 billion parameter model, it is an LLM because they have certain emergent capabilities. It can generate new text when you feed in original. I mean, you ask it to complete a sentence, it will be able to complete a sentence. If you take a multimodal LLM, it will be able to generate new images. So these make the generative AI models different compared to the original machine learning models that we were talking about. So now when we are talking about the applications, right, so they have entered into text, as I told you before. They can generate text. So when you ask it to complete a paragraph, or you ask it to write a book or story, it will be able to do it for you. Then you have video generation capability. So now at least like 3 minutes or 5 minutes video you will be able to produce using a LLM, vision LLM. And coding is a very important part. So you go to an industry, right? So what you are expected to do is, as a developer, you program, you code. So now this generative AI has made the work very easy for us. Later in the second half of the session, I will show you how to leverage on the generative AI's capabilities to use or generate our own code. Okay, so this is something that I will cover. So then you have music. So now LLMs can produce music, and they can generate synthetic data for us. So earlier when we were training a lot of models, the problem was getting the data. So if you're talking about an industry is a closed environment. So you will not be able to get access to the data very easily. So even when you get access, the data that you will have will be very imbalanced. So you will have positive samples, more positive samples, like thousands or something in that number, but negative samples will be only 2 or 3. So let's say you talk about a motor producing company, an engine manufacturing company. Okay, so the fault that will arise will be very minimal, because the pipeline is very streamlined in such a way, they are fault tolerant, so they will not fail very easily. But when the fail comes, or when the fault comes, the cost is very high for them to rectify. So they would want to minimize the fault. So this is a general problem which industry people generally will come to us. But what happens is, when you are looking at the data pipeline, you will have thousands and thousands of positive samples. But when you are looking at the negative sample, like how many faults that has occurred, it will be in like few digits, like tens or 20s, that's all. Because traditionally they are not supposed to fault. This happens in the semiconductor industry as well. So let's say you are manufacturing chips, RAMs for example, or data storage. So now your fabrication unit, it has to produce all these fabricated parts without failure. So the failure rate has to be very, very minimal. The margin of error is very small. But when the error comes, they cannot take a risk. They will throw the entire lot out. So let's say in one lot they are producing 20 chips and they found one failure. They will throw the entire 20,000 lot. So their cost for failure is very high. Okay, so they will want to identify where the failure is. So which part of the process has failed, so that next time when they run, they will overcome that failure. So this is a very common problem in semiconductor industry. Okay, now when you are looking at the negative samples, it will be in few hundreds, because the cost of failure is very high. People will be very careful not to make any fault generally in the semiconductor industry. So now when you are training a machine learning model, you cannot just take the data that is coming out, because the data will be very, very imbalanced. So you will have more than 100k positive samples, but only 10 or 20 negative samples. So if you are going to train a machine learning model with just this data, it will never work. So this is why practical learning or theoretical learning, what we learn in our colleges, is very different from what we do in industry. So we will know how to train the model, how to use the data, how to build a data pipeline. But when you are thrown this problem at you, it will be a very different problem. So now you cannot use traditional machine learning ways to solve this problem. So you have to mathematically model each of the data pipeline, like each of the step you will have to model mathematically, then find out what is the probability of failure here and why that particular data point has made this error. So all these things you have to take note. Only then you will be able to have a full mathematical model of your end-to-end pipeline. So this is something that they do. But now with the onset of generative AI, you can create negative samples. So this is a very big boon for us. Now you pass in the data, you give like a few examples of negative samples, then you ask an LLM to generate more variety of negative samples for you. So this is called data augmentation. So now you have enough data for you to build a machine learning model, but still it is synthetic data. It is not like a proper original data, but it can generate synthetic data in a much cleaner way compared to the earlier technologies. So this is a very big boon for us, this data engineering. Then you have the metaverse or the simulated world. Now the LLMs are coming in. So recently even Facebook, they launched their Ray-Ban glasses, where you will have the live feed going into, then you do some image recognition, then you pass real-time information on the glass itself for the person to see. Even Apple, they came up with Apple glasses, right? So all these things are, like very early stage technologies. But the underlying principle is still the same. So it is computer vision. You are accessing data streams. But the difference between theoretical and the practical world is you have to use all these data streams efficiently. Okay, let's say you are looking at this Apple glass. You are wearing it on you. So you have continuous data stream. So every second you will have 60 frames. So 60 frames is 60 images for 1 second. So let's say you are wearing it for 1 minute. So you have 3600 images. So then you multiply by number of minutes that you are wearing. So this data is continuously coming in. Then you have to decide which of the data is important. So you cannot simply have like a filter or a sliding window based mechanism that, okay, so I will only choose data from this window. So it will not work. So you have to efficiently store the data and you have to efficiently retrieve the data for the user. The user will tap saying like, okay, so I want this information. So then you have to, so you will have billions of data there in your data store. Now you have to, within few microseconds, you have to retrieve the data and show it to the customer. So if you delay beyond a certain point, then there is lag. So then the user experience is faulted. So the industry will not accept something that the user will not want. So this product will be a failure. So if there is a lag, you can straight away say you cannot bring it to production. Okay. So when we are talking about proof of concepts, so we are only showing that a particular concept can work. So I am just showing the proof that whatever I think as a solution is feasible. Okay. Then this particular proof of concept will move to MVP stage, which is minimum viable product. Okay. So what is that is, so you take this particular proof of concept and build it as a product in such a way that you don't incur very high cost to the company, but you still make a product out of it. Okay. So then this is the product that they will test in the field. So they will send it to all the users, or like they will have initially select group of users where they will launch this product. They will get the reception. Then there will be MVP 2, MVP 3. Then only then you will go to full-fledged production. So when the feedback comes, you have to incorporate all the learning back into your product. So this is what a product development is. So but most of the time when we are looking at research and development, we don't do a lot of development. The development is very, very minimal. So what we do is active research. You find out or you prove that particular technology can work, or you prove that some innovation that you can make in your pipeline that will minimize the cost for your product that you are going to develop at the end. So all these are the ones that your research team will focus. So each team will be built by a lot of scientists like me. So there will be a lot of senior scientists, and there will be a lead scientist, and above that there will be a director. Okay, so the director will decide what are the products that we will be focusing on, or what are the proof of concepts that we will be focusing on. So the timeline usually that will be given to us is 2 weeks. So 2 weeks is a golden period. So beyond 2 weeks they can extend for 1 more week. So 3 weeks is the maximum time they will give for a proof of concept to be developed. So this I am talking about a research industry. So when you are talking about development, it's different. So I come from a research background. So this experience I'm sharing. So you will be given only 2 weeks. So within this 2 weeks, you have to prove a concept, which means you have to break down your very big problem statement into smaller problems, and you have to provide solutions. It can be existent already. So you can take existing solutions, patch together and bring like solution out. But or you can think of a new way to approach this problem and solve it. But most of the times you will be given only 2 weeks. Okay, then once this is started, every day there will be knowledge sharing session, like okay, what did I do now that can help me to accelerate this development or this research. So initial 1 week we will only do literature review. We will find out how this market is being used in the industry, or how this particular problem is being solved in the industry. So this will take the chunk of our time. So after that we will find out our competitors, like who are already existing in the market, who have provided this as a solution. So we will try to adopt some of the ways that they have done, so that we don't waste time, right? Okay, so already there is a product out, we know how it works, so we just try to reinvent the wheel. I mean, like, do the same thing again, don't reinvent the wheel, we just take their solution. But most of the times this thing is closed source. You will not be able to know how they made that product. You can only do the guesswork, like okay, so this is the part where they made some innovation, so and this is where I have to make that innovation. So that identification you will have to make, and you have to plug that part. Rest of the part you can is going to be the normal thing. Okay, so this is how usually the research thing works. So beyond that 2 weeks, if the lead or the director see no improvement, or he feels that okay, so this is going nowhere, he will throw away the solution. So we will move on to the next thing. So you have to have that mindset, like continuous changing mindset. So you have to change from one problem to the other problem. So the space of this problem will not be the same. So it will be changing from one space to the other space. You have to immediately switch. You have to change your thought process. So this is something that keeps your brain alive, because you are not doing the same routine again and again. But it is very challenging and it is very stressful, because you have only very limited time to come up with a solution. So sometimes they will give you only 1 week to come up with your POC. So you have to think of very different or some innovative ways to break down the problem into simpler ways, and patch together and bring out a pipeline for them to visualize. So the end users that we are talking about, they will not know the technology. So whatever the machine learning model you use, even LLM you use, they don't care. So what they will want is the final solution. So let's say you have a fruit classification company. So it has to classify if the fruit is ripened and what is the stage of the ripening. So all these things it has to classify, the machine learning model. So the end customer, he will not care like what is the success rate, how much is the accuracy, what is my F1 score. All these things he will not care. What he will want is what is the final output, what is the number of failures that I have, so how many misclassifications that I have had. So this you have to speak in the customer's language. So you have your team lead and you have your director who can understand your technical language, but then you have your customer who does not care about your technical knowledge. He will only want the on-field information. Okay, so you will have to communicate in both the directions. So you have to break down your problem so that you can get help from your senior person, as well as when you are presenting a solution. Let's say your model is 90% accurate. Okay, so you don't go to the customer and say that okay, so I have built a machine learning model which can accurately classify 90% time. He will not understand. Okay, so now you have to break down the problem saying okay, so you have 10 fruits, I can get 9 of the fruits correct. Okay, only one of the fruit may be wrong, and one of the fruit usually gets misclassified, belongs to this class. Okay, now the customer will think okay, so this is not very I mean whatever that is misclassified is not very important to him. Even if it is misclassified, he does not have to worry. So he has to worry about the other chunk, which is the meat of the problem. And if that is all the times coming out correctly, he will be happy. So he will take that to his company and he will deploy. Okay, so this piece of information that you have to break down and pass it to the customer. So this is one skill that we have to develop when we are working in the research industry, because when in the research industry we tend to focus more on the technical details, like okay, so what technology did I innovate, so what model did I use, how did I efficiently optimize my data pipeline. All these things we can have, but it is not going to serve the purpose at the end. So at the end, what happens is how the customer is happy. If the customer is happy, then your product has a good success rate. So be it your team lead or be it the customer, so you have a different audience. So you have to speak in that way. Okay, sorry, we have digressed. Okay, let's come back to our generative AI. Give me 1 second. Okay. It is again starting the slideshow. Okay, so let's go. Okay, so now I am going more into what are the everyday applications that we can use an LLM for. Like, okay, so you have all these topics and you can have other topics as well, but I am covering only something that I think is relevant for our everyday use. Like I have split it up into different sections like productivity, finance, health, content generation, education, then travel. So these are the ways an LLM can help reduce our time or effort. So this is what I think. Let's say you are talking about productivity. Now let's say you have a code and you want to document, saying like, okay, so this particular function is doing all these things. I have all these variables and I have to modify all these things. So you have this piece of code. Now you pass it to an LLM, ask it to document it. It will neatly do all the documentation for you. Previously, it used to take 2 or 3 weeks for us to just do the documentation only. But now it is in a matter of seconds. So you don't waste your time doing the documentation. You just send your piece of code to the LLM and ask it to document. It will neatly do it for you. But what you have to do is verify that the documentation is done correctly. So that part is still not taken care of because there is no feedback mechanism. Let's say you are able to generate an output, you will not be able to know that this output is correct automatically. So you have to manually intervene to check manually. So this is one active research area where people are trying to evaluate the output that is produced by the LLM. So these are different research directions. Okay, then we go to finance. So you have the expense tracking, budget tracking, and you have the fraud detection. So all these are some of the applications. Then health is like, so you have the health support. So you can ask an LLM, like you tell the symptoms. Okay, so now I have cold, I have blocked nose. So what could be my problem? And when should I go and see a doctor? All these things you can ask an LLM and it will be able to give you an answer, but you take it or not is your prerogative, but it will give an answer for you. Then content generation, this is what is being used by most of the YouTubers or Instagram people. So you have the image and video generation, music and voice. Now even in interviews we are getting news that people are using AI to simulate their faces and their voices. So it is like somebody is doing the interview, but they will match the face with the interviewee and the voice also they will match, and they will create a seamless real-time video stream of this image mapping. So sorry, earlier we had this problem like morphing certain images with certain faces. So this is still a problem, but that technology has advanced in this way. So now you can mimic the voice, you can lip sync the way that you are speaking with the simulated video, and you can pass it on to the end user without the end user recognizing that this is a AI generated content. So now this is going on, and we have certain instances where we have identified that people are using this in interviews. Okay. Then when you come to education, you have the AI tutor code. Let's say earlier we were talking about these big FANG companies like Facebook, Amazon, Google. All these people, they have their initial rounds where you have to do lead code based problem solution. Okay. Now you take that problem statement and pass it to the LLM. Few seconds it will give you a very optimized solution. Even very good time complexity, space complexity, all these things will be taken care of, and it will give you a best efficient solution. And people are using this in interview. So now when you, so you just have to be innovative, find out ways how to use this, and you will be able to successfully use it. Okay, then travel is route planning. Like, so you pass in key information like where you want to go, and ask it to route. I mean, like, do the travel planning to the LLM. It will even communicate with the travel agent, book your tickets, hotels and everything, and pass you the final schedule. Like, so these are the things that you are going to look at, and this is how you are going to travel. So the technology is there now, which we can leverage on for our everyday use. So we don't have to rely on or spend our time on all these things which the AI can help. So that is what I am going to show you. Okay. So today I am going to focus mainly on this expense tracking. So because I think, okay, so expense tracking is something that people would generally want to use, and I will show you how to or how the LLM has advanced in doing the basic tracking. I mean, like, there are a lot of mobile applications now in the market which does this expense tracking. So you just have to pass in your bill, whatever, then it will give you the segment wise comparison, like how much you have spent, what is your major spending, all these things it will be able to do. Now today what I am going to do is I will show you how to program your own expense tracker using an LLM, and I will do from the scratch, like how to set up, how to start calling. So all these things I will show you, and I will also describe the problems that you will face, because when you are talking about building a solution, as I told you before, the evaluation is still not there, the feedback mechanism is not there. It will give you an answer, but it is you that you have to know that the answer is wrong, and prompt it again, asking for a good solution. So this part you still have to be knowing. So I will show you how these things are done. Okay, so for this expense tracking, right, so you have different segments. So like you have the split up like essential spending, variable spending, financial spending, health, travel, emergency and education. So these are the different segments usually that you can build. So you can pass these as inputs to the LLM and pass your grocery bill or any bill that you have, take a photo, just send it to the LLM and ask it to keep track based on this bucket. Like, you have the essential where you have to pay the rent every month, so you have to pay the current bill or internet bill, so you have to get groceries, you have to travel every day to school or office, then you have to pay insurance premium. All these things are essential spending which you cannot avoid, you definitely have to pay. So then you have the variable where you are going out to a restaurant, you are spending this much, so this is a variable which it can track. So all this information you can pass it to the LLM saying like, okay, so these are the buckets that I want. You classify whatever piece of information that I give you into either of these buckets, and finally you show me an analytics on past month how much I spent, or past week which categories I spent more. So this is for people like me who tend to forget what they are spending on. So you go, you spend, then you forget, but at the end you will think like, okay, so I have spent this much, where did my money go? We will not be able to know. So but if you are able to track yourself, you will eventually reduce the wastages, or you will at least know, you will make an informative decision. Okay, so this is something that I will feel happy, so I will be okay to spend. So this informed decision that you can make instead of worrying at the end saying where did my money go. Okay. Okay, so now when we are talking about this expense tracking, you have these three ways. Okay, so this expense tracking is not something new. So even like in the older generation, my grandfather or his father, so he used to do expense tracking. It is not something not done or something new. People have been doing this, so but they have their manual way. So let's say you go and speak to your grandmother, how she knew how much liters of milk she bought. So earlier, now milk comes in a packet, so you just order, it comes and gets delivered to your doorstep. But earlier times, some people with the cow, they will come with their bucket, then they will give you the milk. So then you will have to know how much liters of milk you bought for that week. Then you pay the money. You don't pay instantly, so you wait and you pay the money. But you have to keep track of how much you have spent, right? So likewise all the groceries. Now you can pay instantly using your mobile phone. UPI, government has made it simpler. But earlier you have to take the money from your pocket, and money does not come easily. It comes only in the salary day. So rest of the times you don't have the money to generate. I mean, like, it is in the rotation. Money has gone somewhere. It will come back to you at some point of time. So this is how people used to function. Even in the kirana stores, where you go to the department stores, you buy this much amount of rice or this much amount of dal. So you tell them saying, okay, I have bought this much, and he will be able to keep track. He will have a record. Either he will write it down, or he will have a very good memory that he will know, looking at your face, okay, so this much he has bought, he has to give me this much back. So all these things were going on. So this is the manual way of keeping track of your financial expense. Okay, so then came these apps. So let's say you have the Mint app, or if you go to your app store, Google Play, or even Apple iOS store, you will find a lot of financial trackers. Like I said, so you just have to take a photo of your image, and they will be able to track your finance. Okay, how they were doing is, so when you pass in your image, they will give you all the guidelines saying, like, it has to be in a black background, it cannot be crumbled, it has to be neatly taken. So all these guidelines they will give you. You follow the guidelines, you take a photo of your bill, and the machine learning model will do an OCR. OCR is nothing but optical character recognition. So it will take the photo, convert all of these characters into machine understandable text. So text is nothing but ASCII code, right? So each of the letter will have an ASCII code, which when displayed to you will be represented as ABCD, correct? So this understanding is done by a machine learning model, and the technology for that is called OCR. Okay, so this has been beaten already. Like, there are many machine learning OCR models which can extract structured images. So, but when you have like a doctor's prescription where the doctor just scribbles like something where only the pharmacist will know, right? You will never be able to do an OCR on it. So even when we read, we will not know what is this thing. Only the pharmacist knows like what is the medicine. So this all these things the OCR will fail. And there are a few instances where the handwriting is not properly recognized, and it has to look at the final output. So some of the bills, they will have their final amount at the top, some will have at the bottom, some will have at the side. So all these are very unstructured bills, and OCR will be struggling to find out the amount, the total amount. So it will be able to extract some information, but it will not get a complete information for you. So this is the state. So even with the best models, okay, so let's say in the market available, ECOCR is one of the open sourced model, which is best OCR model. So it is machine learning trained, and you can use lot of switch different models. They have different language recognition. So you can take a photo of something written in Hindi or French, and you can ask it to summarize what is inside that particular image. All these things ECOCR will do. Surya OCR is there. So all these things are state of the art in the market for the OCR. Okay, now but with the onset of the vision LLMs, right, multimodal LLMs, you take this image, pass it to the LLM, and ask it to extract a table or extract the information or just do a summarization. It will neatly do, because it has been trained on all these bills and such. Because you have to feed in lot of data, right? Like lots and lots of data, and obviously all these data will have some of these bills, and it will already be trained to recognize all these OCR text. So LLMs now are able to do better OCR compared to whatever that is available in the market. So I'm sorry. Okay, so this is the current trend. But when you are talking about an LLM based solution and a traditional machine learning based solution, so you remember when I talked about cost. So the industries mainly will focus on reducing the cost for your pipeline. Okay, when you are looking at a machine learning model, even for OCR, so this serving mechanism is already fully optimized. So you can serve a model using DeepStream, or you can do even without DeepStream. You can just serve it locally, just using one edge device. You will be able to do a local OCR. So all these things are beaten. But when you are talking about an LLM, when you are sending your data, these models are not free. These multimodal LLMs, they are not running for free. So you have to pay some cost for the technology involved. Like, because they are the early thing, right? I mean, they control the market, so they define the cost. So when ChatGPT came out with the multimodal LLM, people wanted to use the vision transformer, like how they did, but you have to pay $20 US dollars for 1 month to get access to how it performs. And there is a rate limit also. Like 1 minute you can make only, I think, 1,000 calls. So beyond that you cannot make. Okay, so let's say you are a human, you do one call, it will go and it will take few milliseconds for it to come back. Let's say 200 milliseconds it takes for the response to come. So once the response is here, so the response will be in a stream. So like slowly the text will populate. So but it will populate in a much faster rate than you can read. So you will take your few seconds or something to fully understand what the LLM has given you. Then go for the next prompt. So maximum you can do is 10 or 20 prompts within 1 minute. So this is how a human will manually question. But when you are talking about automation, right? Now I am going to use this OpenAI model to generate synthetic data. I know what I want to generate. Like within few milliseconds I can generate new questions and ask the LLM to give me answer. An answer I don't have to read, I just have to store. So there is no manual checking of the data. So this is one thing. So when the data is generated, it is generated in millions of records. You don't go and read each of the record. So it gets generated, it gets stored. So now if your hardware is very good, you can definitely make 1,000 calls in 1 minute. So this is why when you are talking about enterprise, the LLMs, they charge you. So now the industries are waking up. So they don't want to do the paid version. So they want to deploy their own LLMs in their hardware. I mean, let's say you talk about a big company like Airtel. So definitely they will be able to buy a few GPUs and they will be able to host their own models which can be fine tuned, and this can serve as an API for you to just use and consume. So this is the route that most of the industries are taking. This is why people are working on fine tuning. So the base models are there. You take the ones that are free to use, like free for commercial use. You take it, then you fine tune on your own internal data, company's data. Then it will be able to answer for your company's thing. So that is what they call it as chatbots. Okay. So let's say you have a voice company, which means you are handling customers' queries in real time. So you have a voice thing. So people are talking to you, and you are supposed to respond in a particular way. So the company has set rules, like you cannot be angry. The customer can ask any sort of question that he wants, but you have to keep your calm. You have to slowly answer. You have to break down what the customer wants. All these regulations that you have to follow. So this is mainly outsourced. This is called voice company. But what happens is the parent company will still want to check, like if they are compliant. Like let's say they are selling an insurance product, they cannot oversell, saying like, okay, so I can cover all these things, but when the real thing happens, they will not cover. Then it is bad name for the company, right? So all these regulations they have put in place, like say you have to speak only certain things. You have to speak in a way that you are legally compliant. All these rules the company has put for the voice company. So there will be automated recording of the way that this employee and the customer speaks, how he has spoken, how he has promised. Then it will be read through by a person and found the compliance. So this is called auditing. So this generally happens. But now with the chatbots, what happens is they can now record both the ends of the conversation. The customer's conversation they can record, then the employee's conversation also they can record. They will pass it to the LLM. Also they will pass the guidelines, company's guidelines to the LLM, and say, ask it like, okay, so now you have 2 audio recordings. I want you to break it down and show me if the employee is compliant. So this you can train based on your internal data. You take your internal data and make it into a question answer pair kind of thing. Then you fine tune your model. Any open source model you can fine tune. Llama also you can fine tune. So you just need a GPU. So now the technology has advanced that you don't need powerful GPUs. Even consumer grade GPUs, you can still use it to train, but it will take a longer time, maybe a few days, if you can fine tune. If you have the current resource or something, you can still fine tune at your home, and you can build your own chatbot. Now you pass these two conversations as text, or you even pass a voice recording to the chatbot. It will say, okay, so this customer has faulted in this particular line, and he has this 70% rate, or like 60% rate, he has to be sent back for training. So all these things are automated now. So this was the first thing that people started doing when generative AI came. So this is called text summarization. So you convert the voice into text, then you pass it to the LLM, and the LLM will be able to summarize the text saying, okay, so he has followed the rules, guidelines set, so he has failed. All these things that the company will be able to say. Okay, then other thing is the medical field. So medical field now, even in India, they have started to follow. So what they will do is they will start to record the prescription in their computer, like what is the diagnosis, what is the symptom, and what is the prescription given. So this digital information is available. So if you are able to get access to this digital information, you can fine tune your model. It can act as a first cut nurse. Okay, saying, okay, so the customer comes in to the chatbot saying, okay, so I have these symptoms. What can possibly the disease be, and what are the medications? Okay, so if the chatbot has access to the customer's previous medical records, it will do all these analysis, and it will say that you have this past history. Based on that, it could be this. But to verify, you have to go with the doctor. So this definitely we will have to add. But at least the customer will know. Now, okay, so this is something that I know, and I can go specifically to the specialist. Okay, so this problem I can go. Or in emergency situations, it can act as a nurse saying, okay, so what is my first aid for this symptom? I have like a very fast heart rate. So what can I do at home to bring down the heart rate? So then it can look at the past history and stuff. Then it can say, okay, you can use your aspirin, which is been already prescribed to you. Just use it, then your heart rate will come down. All these suggestions the LLM can do. All these are live products, what I am talking about. So this came in 2 or 3 years ago. This is not something new. So this was done within 2 or 3 months of the ChatGPT's onset. So when this field got merged, right, I was talking about earlier, computer vision and this thing got merged, this started. So people started fine tuning based on the data that they already have. They built their own models and chatbots. Now most of the chatbots that we see are fine tuned on custom data. So people came up with different ways of fine tuning. So you can do parameter efficient fine tuning. You can adopt Q-LoRa strategy. So if you look at how the mathematics is there, so you can know how the Q vector and V vector, which layers you have to lock and which layers you have to adapt the weights. All these things you can manually go and explore and find out. Then you can build your own fine-tuned version of your model, and it can be instruct fine-tuned so that you will be able to build a chatbot. And when you ask your questions, it will be able to respond in the way that you want. Okay, so this is something that we can all do at home. Now the technology is there. Okay. Okay, so now I am going to go with this chatbot thing. I am going to show you how to leverage on existing technologies that are available. You don't have to fine tune. You don't have to spend money, but you can build your own chatbot with the existing resources available. So that is what I am going to show you, and I am going to cover step by step, like how you can, as a novice, you don't know anything about programming, but you still want to do a chatbot which can track your finance, like all your spending and stuff. So I will show you how to tackle that. Okay, so in the market you have different service providers. Like you have OpenAI, you have Gemini, you have Meta. So Meta have launched all their models as open source. So their Llama models are open source models. Anthropic, then OpenAI, Gemini, they target end users who are individual users as well as enterprise users. So it can be paid, it can be free. So it's a double-edged thing. So if you go with some of their paid models, your answers would be very good. So this we have to agree. So the paid models are somewhat good, but you can still do it for free. So that is what I'm going to show you, how to leverage all these things and do it for free. Okay. Okay, so this is something I want to show you in live, like how you give a prompt and how it can do. Okay, so do you guys want to take a break? I can take like few 2 or 3 minutes break to gather your thoughts. Then we go to live demo or live show. Is that okay? Like we can take a break for a few minutes. Really different. So here I am going to show you how to code. So maybe I will just quickly go. Okay, so what I have here is okay, so to bring you all, ground you all, so we are going to build an expense tracking chatbot for our daily use using a free resource, or like build your own chatbot kind of thing. So that is what I'm going to show you how to do. So for this, what I did is I just googled for some of the receipts. So you can actually try it with your own thing, but usually I don't take paper receipts, so I only take digital. So digital is usually easier. So because there are two different formats of image. So one is digital image. So the other one is manual Xerox, or you take photo of your physical receipt. So these are two different things. So why they are different is, so if you take one image and if you just move your mouse over it, like scroll, if you are able to select the text, OCR will do better. So these are called digital images. These are very easy for models to recognize. But you will have certain images where you have scanned images. So all these receipts, you will have scanned photocopies or Xerox photos. So those images, if you scroll, it will select the entire image. So those all machine learning models will struggle. So even LLMs, some of them they will struggle. So only very good LLMs, they will be able to handle these kind of images. So in industry, what we do is, for these kind of digital images, we will combine OCR, traditional OCR plus LLM. So we will first cut, we will send this data to a machine learning OCR recognition model, extract all the piece of text, store it aside. Then same image we will send it to the LLM, extract this. Then we will send these two separate information to the LLM and ask it to combine. So that will be a data enriched thing. So this will be able to solve almost 95% of your data ingestion. And most recent OCRs like EC OCR, Surya OCR, they are very good. They will be able to extract even for difficult images. It will be easier. And if you are looking at all the very high billion parameter models like Gemini or OpenAI, so they do better OCR compared to XGen models or the Llama models. So even though they are very high, or even Falcon, so even though they are very high parameter models, they sometimes lack when we are talking about OCR. Okay. So what I did now is I just took one image. I can pass it directly as a link, but for simpler thing, I just downloaded and saved it. Okay. So I will show you. So this is what the image is, right? Okay. So let me show you the difference. Okay. So this is we all know ChatGPT, right? Okay. So if you just pass this as okay, where is the thing? Okay, multimodal. Okay, let's go to multimodal. Okay, I will add an image. Okay, so let me go to downloads, bills. Okay, so this is where I have saved that image as a bill. Okay, so now it is uploaded. So this is the data ingestion pipeline. So ask anything. I'm going to ask the prompt where I have here. So I'm going to send the same prompt for both the models. Okay, so let me go up. So this is a grocery bill. Grocery bill. I want to extract all the information. Okay, this is a very basic prompt. Okay, so there is something called prompt engineering, where you ask specific questions to the LLM in the way that LLM can answer. So you can ask any question to the LLM. So how you formulate your question, the LLM will be able to give you the better answer. So this is called prompt engineering. So what we are doing now is prompting. So we are prompting the LLM saying, okay, so this is a grocery bill. Okay, so you can say this is a medical bill. Then it will be able to understand much better. So you can just say, I want to extract information. So some of the generic models will be able to extract, but when we are very specific, So when you are very clear on what you want to extract, the models perform better. Okay, so now let's say I just run. Okay, so this is the image that I upload. So it is processing, it is analyzing. Okay, so in the meantime we will also do the same thing with another model. Okay, so it is already storing us, giving us the information. Okay, so this is what I called as stream. Okay, so what happens is when the result from the LLM comes, it comes as chunks. Means it will not give you the entire answer in one go. It will split your data. But when you wait for the data to fully come aggregate, then you can display. So these are different ways you can display the output to the user. So now it is a user interface problem. So how you want to display the output. Okay, so this is called streaming. Streaming is as and when the data comes, you just push it to the user interface, so that you will not have that user experience of waiting. So now that waiting is removed, you will take your time to understand. Before that the streaming will be done, so you will be able to get the answer. So it has extracted all the information like items purchased with the price. Okay, this is the state. So this is very good, right? Very simple receipt with a very clean background. Okay, it has extracted all the information, so it has put you all the thing, and it is in a structured. Okay, so it is now telling you if you need this in a structured format like a table or a CSV. Okay, so why structured format matters is, okay, now let's say you are building a pipeline. Okay, what it has given us now is a piece of text. This entire output is just text. Okay, next if you want to store this information, you have to process this text. Okay, so you have to find out where the exact answer is. So it will append with a lot of additional text like, okay, so can tell you a story before it gives you an answer, and after it has given you an answer, it will again tell you some things. You don't want all those information, you just only want the information that you are interested in. Okay, so this is why structure matters. Sorry. Okay. I'm sorry. Okay, so now okay, I will, before I go to do that, I will just show you what is the difference. Okay, so I will copy the same prompt and go for Anthropic. Okay, Anthropic is a French provider, a competitor for OpenAI. People also use it. Okay, so let's say the same prompt only I am giving you. Okay, and I am asking it to extract. Okay, so okay, so this says that okay, it is not able to respond. Okay, again, so this is because it is asking me to pay for it. Okay, so but you can try, it will be able to give you the same answer. Yes, sorry, I forgot. Okay, let me upload that. But I don't think it will still accept my thing, because it is asking me for a license. Okay, so you see it is asking me to upgrade to, because I have overused it. So yes, sorry, yeah. So what I showed you is that, right? I mean, like, no, free version, not non-premium. So they will let you use it. Okay, so later I will show you how to do it in the program. So that is much simpler. Okay, what it has happened is it has ingested our image and the text, and it has sent it backend to one of their servers. So it can be in US or somewhere, and they will do the processing and send you the data, right? Because that is what. So this Anthropic used to be free, but I was using it as an alternative for OpenAI. So the license has expired, I think. Okay, so let us come back. Okay, now, so now as I told you, you want the data in a structured format. Okay, so LLMs, they can give you different formats. They can give you CSV, they can give you Markdown, they can give you JSON. But which one would be beneficial for you. So that is something that we will have to decide. Okay, so when we are talking about markdowns, it will be easy for us to visualize. Okay, let me tell you. Give me this table as a markdown. Okay, so you see this is human understandable text. Okay, now what we have done is we just asked it to give this table as a markdown. Okay, but still we have this problem, right? This markdown we cannot digest now, so it is still problematic. Okay, so it has given us in a way that we can see it now much better if you just copy and put it in a markdown.md document, and you can serve it in your website. I mean, like when you launch this thing, it will be neatly formatted and visually appealing to you, but you can still not process it in your background because it is not structured. So it is eye pleasing, but it is still not helpful. Okay, let's say we ask it to do it in a CSV format. Okay, CSV is comma separated values. So this is the format that we generally use it for data ingestion, because you have very little chance of making a mistake, because every field you have to add, and whatever the field is not present, you have to leave it blank or empty. So now this CSV, whatever that it has produced, right, you can see it is not easy for us to read, but it is easy for the machine to understand. Okay, so now I can take this text and split the line by line using comma. So now I will have separate fields. So item, quantity, size and price, I will have it in a separate field. So this I can now push it to a pandas data frame or even a database. So once I have it, I can do further processing. Okay, so this is one way. Another way is which generally people use for table is, so this is for regular usage outside of LLM environment. But when we are talking about LLMs, right, LLMs generally do well with JSON. Okay, so JSON is what will happen is it will give you dictionaries which you can directly upload to Python. Okay, so each of the row you will have the row number, row name and the column name. Okay, so you see you have the item, you have the quantity, and you have the price. So each of the specific line, so you know what the value is corresponding to. Okay, so now I can store just like this as a table and use it to send it to an LLM. I cannot send a markdown to LLM because markdown is good for human eye but not for LLMs, because LLMs, they convert your text into numerical values, vectors, as I told you. Okay, so if you convert this entire line as a vector, each of the LLM will have their own way of tokenization. So the tokenization can be two letters, 3 letters, or one word, or based on the space, all these things. So it might differ. But at least you will be able to associate your column name to each of the values when you are passing it as a JSON. So when you are asking a question back to the LLM, it will be able to understand much simple in a simple way. Otherwise you will have a lot of problems. So this is called prompting. So when you pass your information in a easy understandable way for an LLM, then your problem is half solved. So now if I just pass it as a text to the LLM and ask it to answer, it may make a mistake. Okay, or even as a markdown it will make a mistake, but CSV it will still be able to do, and a JSON it will be able to do. So best possible way to process tables with LLMs is this one, JSON. Okay, so now let's get back to very sorry. Okay, so can you Okay, so here what I have done is, okay, so you can look at certain things. Okay, so we are asking it to do financial analytics. So I am assuming the LLM knows what is financial analytics. Okay, so I can further break down this word into what I exactly want. Like, okay, so generate a profit and loss, do something like that. So I can actually break it down and say what I want to do. Another thing is using this tabular data. So what I am telling the LLM is I am grounding it, saying you don't consider all the other information, just use the tabular data and give me an information. Okay, so this is how you communicate. Okay, so you make it more clear, right? So you are very specific. So you can also say use only the data here, because now these models have access to the internet. They can do this is a very simple problem, but when you are talking about a bigger problem, it can go and access internet and get you solutions which you don't want. You only want answers to what you are providing as context. So now the context is the table or the grocery bill that I have uploaded. So I only want answers from the grocery bill. I don't want answers from any other bill that is available in the internet. So now I have to ground it, saying okay, use only the data here, and I can still say don't hallucinate, don't generate your own answers, just use only the real answers. So all these things are grounding words, make the LLM answer only to what you want to do. So you be more specific. I can now just say can you do some financial analytics. So that is also a way, but you will not, you then your evaluation is difficult now. So now you have to look word by word, letter by letter, saying okay, so what it has outputted, is it an hallucination? Hallucination is something that is not present in the text, it is producing some answer. It is because these generative AI models, they can generate their own answers, right? They are good to do that. So but instruct models work as a chatbot. Before that, the base models, whatever that were there, they are like this only, they are generative models, so they will generate text. So when initially the models got launched, a lot of hallucinations were there, but now it has come down, but we still follow the process. So hallucinations we try to minimize. Okay, so I am going to send it to it. Okay, okay, it has neatly summarized for us. So what it has done is, it has done basic statistics, category based insights, price distribution analysis, and key spending observations. So these are things that we will want in a financial analytics document. So you take a company annual report, same thing you ask it to do, so it will be able to give you all these insights. So this is the piece of information that will be beneficial. Okay, still it is all text, right? I mean, like we will not be able to appreciate. Okay, I am going to ask it to plot charts. Can you so again I am saying only this information. I'm not I'm grounding again, right? Can you show me this information as charts? So it is generating the charts now. So it is saying okay, so it will do a pie chart and a bar chart, so category wise spending and price distribution. So these are the information that we generally want, right? Okay, so you have category wise spending, so you have fruits and vegetables, packaged meat, household and dairy, and what is the price distribution for each of them. So this chart now it has produced, okay, very nicely and neatly done. Okay, now all these things you have generated using OpenAI is in their user interface. Okay, the model is their model, the user interface is their user interface. Whatever the text and the chart it has provided, you can either copy paste or you can just read from it, right? I mean, like you cannot do your own chatbot. Okay, so this is the limitation of using this user interface. You can similarly upload your research article, like you want to find out key contributions from this paper, right? You download the PDF, upload it to the LLM and prompt it, ask questions like what is this paper about, what are the key contributions, why is this technique revolutionary, all these things it will be able to answer and give you. So you can use it for research also, okay, but you can understand what is going on. Okay, now the next part is it has actually produced charts, bar graph and the pie chart. Okay, underlying backend, what it has done is it has run a program to generate. Okay, so front end is this, so which means you see the user interface where you see a neatly done chart and a neatly done bar graph, but background it has run a program and generated this charts and it has given us this thing. Okay, now I am more interested in that process. Okay, can you give me the okay, so can you give me the code to generate these figures? So it has understood because it knows my favorite language, so it is Python, so it is doing the thing in Python. Okay, now it will neatly do all the documentation and it will give you all the functions, but if you straight away take it and run it, it will not run. That is the problem. So sometimes it will run, sometimes it will not generate in the way that we want it to generate. So you have to understand which piece of information that you wanted to take from this. You can either take this as an entire thing, run it and use it as it is. Okay, you are free to do whatever you want, right? You can take it, you can modify it. Now you have to find out which piece of information is relevant to you. Okay, now you look at this thing. So it has manually assigned categories and it has manually assigned category spendings. So this is something that it has extracted from the table and grouped it as different things, right? And category spending also it has extracted, did some analysis and found out these values. But when it is doing the chart, what it has done is it has manually inputted these values. So this is not going to help us when we are doing our own financial tracker, because we want to do this in runtime, right? We don't want hard-coded values here. So this is a hard-coded value. Likewise for the price for data distribution, right? Each of the item it has extracted neatly as text. Okay, then it has put it as a hard-coded value. Okay, either you have to process the text and get this piece of information yourself. So this is the tricky part, the data manipulation part. So the LLM has identified all these information, but how do you feed it or how do you extract that piece of information? So that is going to be the tricky part. So rest of it, the how to define the subplots, how to define the labels and all these things is okay, you can take it as it is. You can pass in the values and it will be able to produce the charts. Okay, so these are the two parts that I want you to focus on. Okay, how you manipulate the data and how you use the LLM to do the work for you, not do it manually. Okay, so this is manual work. I don't want to do it manually. I want the LLM to help me do it. Okay, so that is what we are going to see in the next part. Okay, so until this part everybody is clear, right? Okay, I can copy and paste it and run it. It will run and it will produce these two charts, but it will not be useful to us. So you know how to, what you can get from this code or piece of code is this part, how to create figures using two subplots. You can take this as an example. You can use it as a code for you. Okay, let me go back to what I was doing earlier. Okay, so now I am going to introduce you to something called Google AI Studio. Okay, so this this is again from Google. Okay, so Google, when you are talking about Google and Microsoft, these two are very highly competitive. Okay, Google is in the search engine space and Microsoft is a provider. I mean, they are technology provider. Okay, so in some of the fields Microsoft is very strong. So the Word, PPT or Teams, all these technologies Microsoft is very strong. Google is trying to compete with them. They created Google Docs, Google Drive, similar to whatever the product Microsoft is using. Google was able to produce, but then it is all web based and they were not able to penetrate into the market. So the key advantage with Microsoft is whatever the laptop they provided, they gave it all the softwares as free. So you get a license there. So you are stuck with the product. So similar launch Google also did. They launched a Chromebook where Chrome is the operating system, and all these things by default come to you. There are different other softwares for processing documents, doing all these things. So even open LibreOffice is there. This is open source. This is what you will use when you are using Linux. Okay, you will not be able to use Microsoft or any other thing that works on Windows, right? So you have to rely on open source. So at the back end we use LibreOffice, and most of the document processing technologies now. So let's say you take Docling, or you have the PyPDF, or whatever the document processing technologies underlying, they will use LibreOffice because it is open source. So they will rely on this open source technology to read and understand all this information. Okay, so coming back, so Google also launched. Okay, so when OpenAI came, Microsoft bought into OpenAI, saying like, okay, so they are the key partners with OpenAI. So Microsoft, whatever they will do, they will integrate OpenAI. So even their search engine Bing, right? So it is a competition to Google, which they were not able to keep up with. So Google is very strong in the search engine space. So they were integrating OpenAI based answers on the Bing. Okay. So Google also came up with their own model, which is called Gemini. Okay. Initially, when they launched, even in their display, or when they launched product launch, right, it had a lot of flaws. People were not ready to accept Gemini as a competitor to OpenAI. But in the back end, what they have done is they have kept on increasing. They have caught up with OpenAI, I would say, and in some of the ways, Gemini models are better than OpenAI in certain things, especially multimodal thing. It's almost the same. You don't see any difference at all with Gemini as well as OpenAI. Okay, now I'm going to show you how to use Gemini. So all these other things, right? Even Anthropic I showed you, then OpenAI I showed you. All these things, when you are going with the API based approach, okay, why would we need API? Now, earlier problem that I have showed you here, right? Okay, so this one, right? This user interface is created by them. We are only the consumers. So we only see what is presented to us. We don't get to see the backend. We don't get to access the real data. We only see how they want to show to us. Okay. If we want to do it ourselves, so I don't want the plots to be here. I want it to be somewhere on the top. I want to change the color. So all these things I want to do it myself. I want it to be more manipulative. I want to be hands-on. So then what we need to do is we need to hit the LLMs, call them to get the response, do all the data manipulation ourselves, then make the chart. So this way you will be able to control the data that you have. Okay. So for this, what we have is we have to call the LLMs, right? So we have to pass our data to the LLM, get the response from them. Okay. So when we are passing the data to them, we need two things. One, where to send the data, then how to receive the data. Okay. Where to send the data is something that is defined by all these plugins. Okay, so you have the Gemini plugin for Python. So I can show you later. So if you go to the API documentation, you will be able to see Python based plugin. You can have React based plugin. You can have Java based plugin. So all these things are different ways to access their model. Okay, now you are able to access, but how will the model know that you are a registered user, or you are someone who is authorized to get this model? Because it is not a free community, right? I mean, Google is hosting, or they are spending money to host their model. They are spending resource, as well as OpenAI, as well as other models or companies. So if you open it like that, if you are like Hugging Face does, if you open it, you will have millions of responses within seconds. So which the model cannot sustain, or the infrastructure will not be able to handle. So they have split it into two. So you have the free tier one, and you have the paid version. Paid version, you have specific resource where you don't have any downtime, you don't have any, all these problems are solved. Okay. So when it comes to free tier, there are very few models which give you free tier when you call the API. Okay, when you go to the front end, all these cloud also, you will Anthropic also you will be able to use. Just that I ran out of my credits, but if you run it, you will be able to work. So these give you their own front end, but they don't give you access to data. Okay, for free. If you want to access the data, or if you want to build it yourself, then you have to pay. So this is how the pricing model is. But Google, what they have done now is they are trying to catch up with the competitor, which is OpenAI. So they have opened access, free access for us to use the APIs. So which means if you can make less than 60 calls using this API, it is free. So beyond that you have to pay. So 60 seconds, as I have told you, right? So 1 second you make one call. So this you don't do as an individual. But if you are in a company where you are programming, do a lot of things, then you will do, definitely you will hit it. But if you are doing it for personal thing, as a developer, this is free. You will never be able to reach that limit. Okay, so this is what I'm going to show you now. So you come to Google AI Studio and you can actually create your own API key. If you click on the API key, it will show you what to do. Like you can, so what product you want to use. So you want to use Gemini API. So then you define like the name, what is the project name. It will give you the API key. So then it says like free of charge. So you can actually use this API to call Gemini model to do the work for you. So that is what I'm going to use it, because it is free. I don't want to pay. Okay. Now again I come to Google Colab. Google Colab is again free. It is not something that you are paying. Okay. You can program, but if you want to use GPUs or if you want to attach specific GPUs, then you have to pay. But basic Python, okay, let me connect to the runtime. I'm connecting to Python runtime. Okay, now it is free. I can run my code here. I can do whatever data manipulation, whatever the things I want to do, I can do here. Okay, so another thing is you have the API key, right? You don't want to share it with others. Okay, let's say you have one API key and you have 10 people sharing that same API key. It is easy for you to reach the limit. So 10 people within 1 minute, if they every 10 seconds they make a call, it will think that you are a company, you are not an individual person. So it is not safe for us to share the API key. Okay. Another thing that can happen is once they get access to your API key, they can find a way to come back to your, they can track your IP, they can hack your computer. So this is one other reason why you don't share API keys anytime, because now we are sending our information over internet. Okay, so we are sending it as packets, so it will have all the piece of information like your username, your password, if you put it. So generally we don't put it. So if then let's say you are making a call with all this information, so then there is a data leak. So then they can access through that packet, extract that information, then they can try to ping to your IP address back, reverse ping, then access your computer from anywhere in the world. So these are some general problems that we have using APIs. This is why it is always recommended to put it in a background, the API key. Either you save it as an environmental file, so you pass as a .environment to your Python script, or you use, when you are using notebooks, you use the secrets and using, so they also give you the code, right, how to access the thing. So this part, Google Colab, I am importing the user data and I am getting the key. So the key is Google API key, right? The name of the key that I have saved here is Google API key. So this is the name. So I am getting the name of the entire content, whatever the value here is, I am putting it inside the key variable. So now when I call the LLM, I have to pass the key here. Okay, so you see here, API key is equal to key. So this part is where I send the key. Now the LLM knows this is me. So I am the only one using, and this computer is sending only this much request within. So they can track now using your API key. Okay, this is the first part that you have to set up. Okay, so next, so here is something where I want to show you, like I am opening the image. Okay, so now you have stored this image locally in my laptop. Let me open my thing. Okay, you can see, right? Okay, I go to downloads, I see the bill, and I have the image saved here. It is the same image, right? Okay, this is what I want to process. So this is what I sent to OpenAI. This is what I sent it to Claude also. But okay, so let's see what it does. Excuse me. Okay, coming back to the code. Okay, now I am referring to the same image, which is this part. Okay, home bill. So you can see where the image. First, we will have to upload into Google Colab. Okay, I go to my home directory. I go to home. If I click here, it will show me upload. I can upload to any of the folders that is listed here. So then I can upload manually where I want to upload. Okay, I have uploaded to home. If I go to home and the bill, I will see it here. Okay, so it is not uploaded. Let me upload. Okay, you see here it is uploading the bill.png. Now if I go to home, okay, I should see the bill.png. Okay, so this is the path. Okay, if you are not sure about the path, right? Okay, so I again click on the dotted line, copy path. I get the path to this file. Okay, so let me paste it here. What is the path? Path is home bill png, right? So that is the argument that I want to pass. So this is the reference to that image. Okay, now I use PIL library. PIL is alternative to OpenCV. So you can either use OpenCV or PIL to read your image. So what it does is it takes raw image and converts it into bytes, so that the machine will be able to understand the images. So this PIL is a library to access all these information. Okay, so I am storing that into an image variable. Next I set up my client. So client is what I call to send my data. Okay, this client can be an OpenAI client, this client can be a ChatGPT client, or this client can be a different LLM client. So but each of these service providers like Google Gemini or OpenAI or Claude, so they have this Python API plugins, right? So they will tell you how you have to set up their client. So this is how they will ingest the data that we send to them. So you have to follow this. So you can actually go to their tutorial, API documentation, right? Okay, so let's go to API documentation. It will show you all the examples. Okay, so I go to Python. So it shows you how to set up a Python client and how to get a response. So this example code is already there. You just have to go search for their documentation. It is already there. Okay, so you set up the client where you pass in your API key. Next is how you call the content, how you execute your program so that the LLM will be able to give you the response. So that is the second part. So once you have the client, so this is the template code, right? You go back to your AI thing. Where is the thing? Oh yeah. So go Gemini developer API, right? You click on Python. So it shows you that you have to call client, models, generate content, and you have to set which model you want answer from and what is the content. So you have to follow the structure. So each of the LLM API service provider, they will have different structure. So OpenAI will have different, Anthropic will have different, Google will have different. But when you are talking about LangChain, so LangChain is one of the provider. Okay, let me come to show you this. Okay, so this is one how do I say, one product. Okay, so they have integrated all the LLMs into their pipeline. So you can have an unified client and the response mechanism. So you can integrate all the available LLMs. So you can have Cohere, you have Anthropic, you have OpenAI, you have Gemini. All these they have integrated into their API. So you can actually set up a single way of calling the LLMs through LangChain. Okay, but for our thing I am going to do it raw, but you can actually go and take a look at this thing. So if you search for like LangChain OpenAI, okay, so yeah, so you see they have a portion for LangChain OpenAI where they will tell you how to integrate OpenAI models into this thing, like how do you call the OpenAI model and get the response. Similar way you have all the other chat models. So let's click on the chat model, right? So you have various things. You have Grok, OpenAI, Anthropic, Azure, Google, so AWS, Cohere. So you have a lot of things. All these things are integrated here. Okay, so now your code is not changing. So you have only one pipeline where you just have to change the model name, and rest of the code is same. Okay, so this is one very good product which industry uses. Okay, getting back to what we have. Sorry. Okay, so I am going to use native Gemini Python, I mean like whatever the API they have. Okay, so their way of calling is you have to specify what model that we have to hit and what is the content. Content is the query that we are going to ask. Okay, so now let me go back. So I have copied and put it here. So I am going to use the Flash model, and content is, you see, extract the contents of this image as JSON. Okay, so let's go back one step behind. Okay, so I want to extract contents of this image only. So I will comment all the rest of the code. So I don't want all this information. I am just going to print the response, what it is going to give me. Okay, if I execute this thing, right, so it will upload this image to Gemini API and it will get me the answer. Okay, you see what it has given me. Do you recognize the thing? So it is similar to what we have done here, right? So let me go up. I don't want to see the code. I will just go up. Okay, so this is the first part where you extracted the text, right? So if you look at the answer here, it is again the same. So you have the supermarket, then all the items extracted as text. So now what we have, so we have the answer to us in this variable. So you have the data already. So now you can manipulate this data into the way that you want to do. So this is calling the API for free and getting what you want to do. Okay, now I will go back to making this into a table, as a table. Okay, I will run. Same thing we did here, right? I mean like I wanted the table. So markdown, you have the table. Markdown, so you have the table. Okay, so next I go. What is the next thing I did here? Table as CSV. Okay, so I want to extract the contents of this table as CSV. Okay, I run. Okay, now you have the comma separated values. You see, so it has extracted the information for us. Now, okay, so I will now go back to JSON, which is what I want, right? So I want the JSON, so I like using JSON. Okay, sometimes when you are using free version it takes a bit of time, but when you are paying for it they will not take this much amount of time. So they will give you the response immediately. But since we are doing this for free, right, they can take or do whatever they want. Okay, now they have given us the JSON table. So you have all the table here. So now this is a JSON string. So it is not like a JSON object though, but it is a JSON string. So this you have to differentiate. Now you asked for a JSON, so it has given us a JSON string. But if you ask for a JSON object, it will it will give you a different format. So now your work comes. So you have a JSON string. You want to change or manipulate this JSON string into a JSON object, which you have a knowledge, right? I mean, like once you have the basic Python knowledge, you will be able to do that. Okay, so that is what I do in the rest of the part. Okay, first part what I do is I replace this JSON tag, which is not going to help us when we are loading this in a JSON library. So I replace this JSON tag and replace all the formatting, this apostrophe thing in the front and the back. So it will get replaced with an empty character. Okay, then I make this as a list. So because that is how a JSON object is. So you will have a list of JSON items. Okay, so I add one bracket in the front, then I add one bracket at the bottom. Okay, now I print this JSON string. So I will show you how this string is going to be. Okay, so I'll scroll up. You see now the JSON whatever that was there, it has been replaced with a bracket, and likewise at the bottom also you have this bracket. So now you have to be smart enough to know this thing. So if you just have this piece of information, then you pass it in the next part, you will not be able to work. So you have to know that this is a JSON string. You have to format the JSON into a JSON object. Only then you will be able to load. So this you have to know. So you have to do this processing part. Okay, this is what we developer do, right? I mean, like we have to use our knowledge. Okay, now what I'm doing is I'm using the JSON library and loading the string as a JSON object. Okay, if I run this, it should execute correctly without throwing any error. Okay, because JSON as simple to use, it is still a bit problematic when you are coming to loading. So it has to be in a very specific way. It will accept. Otherwise, it will throw a lot of errors. So you have to be very clear on the formatting. Okay, now it did not throw us any error. So it has loaded the data as a JSON object in JSON table variable. Okay, so let me go to the next part. So this part is clear, right? Scroll. Okay, so what I have done here is I have now asked the LLM. Okay, so now I have a JSON object. I want to process this, but I don't know how to process. So what should I do? So I will go and ask the LLM again. So how do I convert this JSON into a pandas data frame? So I am going to ask it. Okay, let's see what the LLM is giving us, because that is what we are going to rely on, right? So we are like a novice. We don't know how. Even this part, right? We can ask the LLM. So I have a JSON string. So you just need to recognize that this is a JSON string. So I have a JSON string. How do I convert it into a JSON object? You can just ask. Okay, I did that myself, but yeah. So now you have a program here, like it shows you an example. So you have a JSON string like that. So how do you convert? So you use this function JSON to data frame. Okay, where is this data frame function? So it has given you a function program, Python program, which will take in JSON and it will convert it into a pandas data frame. It has given you, and it has neatly put in all the conditions, like if it is a string, if it is a dictionary, if it is a list, because JSON can be in different formats. It can be a JSON string, can be a list. What we have done now is we have made it into a list. It can be a dictionary also. So and then if the JSON is empty, all this very neat. So you can, but you have to understand the code, see what it has given us and take it. So what I have done is I have taken that code, and it will also explain how to use it and what are the different things that it is doing. So if you want to learn how this function is done, you can still use all this information to understand how it has programmed. Okay, now what I have done is I have just taken that whatever it has done and made it into my function, and I am passing the JSON string to it. Okay, so I can pass a string, I can pass a list, I can pass a dictionary. So now I am passing a string. Okay, so I am calling the function JSON to data frame, and it is loading the data frame. Okay, now you see you have the items here, the data frame items. So it has given you a data frame with the data that you have. Now you can use this pandas data frame to go and do all your charting or data manipulation, whatever you do. Okay. But okay, so next what I am going to do is I am going to show you. Okay, so you go and look at the items. So you see the chunk of the information is here inside this item dictionary. So this is what we will want to use for plotting. But for the store information, and this is like metadata. So where I had used it. So if you want to use that information also, well and good, you can store that in a variable. But the chunk of information is inside this items. Okay. So what I have done is, this is a list, right? So this list has few items. So I have to recognize that this is a list. Then I process the data. Okay. So now let me go back. So I pass in the data table, and I pass in the first element of the table, and I just pass in the items. I don't send all the entire table. I just send only the items, the dictionary items. Then ask it to convert to data frame. So this is what it will do. Okay, so let me go back. So see what is there. What is the name here? It is capital ITEMS. I have put in small I. Okay, because yesterday night when I was doing, it has given me small I, but today it has replaced to capital I. Okay, now I change it back. It is still throwing error. Okay, let me go. Okay, now we are going to debug. Why is this error coming up? Okay, let's see. I will create a code here, and I will print only the part that I want to see. Print JSON table of 0. Okay, so this is the first part I want to see. So it is going to the supermarket, store, and the items. Okay, now I want to list the supermarket. Okay, so now it has given me that extracted portion. Okay, now I want to go to inside this. You have to go to items. So it will give me the items. So now it has given me item, all the separate items. So it has changed the structure to compare to what I had done yesterday. So now since I did the step-by-step debugging, now I know what is the mistake. Okay, so now I have to change this part, add this part. And run the code, and it will give me the same data frame that I wanted. So this is the data frame that I am going to use for plotting, right? So now I am able to extract. So this structure you can specify to the LLM. So now I did not specify to the LLM, that is why we had this error. I mean, like, the structure has changed compared to the original pipeline. Now the pipeline will break if you automate this, because the LLM can give you different JSON structures. So you can give the template JSON also to the as a context, saying, okay, so I want to extract this table as JSON. Then you can say, in this template, in this format, then your structure is defined, so it will always be uniform. It will give you the same structure. Okay, I did not do that, but just keep in mind. Okay, now what we have the pandas data frame. Okay, now what I am going to do is extract the contents of this image and do some financial analysis, which is what we did earlier, right? Okay, so it will do the contents extraction, then it will give you all the listing, like spending category, what is the dairy, what is the produce, all these things it will give you. So it is same as the what we are doing. Okay, now next is extract the contents of this image as JSON and do financial analytics and make charts using Python. Okay, this is the prompt which I also did to the LLM, right? Okay, so now it has extracted the content and it has done some financial analytics, and it has given me the Python program to make the plots, so which is here, right? So again, when you come back here, so you have the manual data here, so you have the categories manually extracted, and you have the items manually extracted as, so which I showed you earlier. In the OpenAI also we had the same problem, right? So it is plotting it. If you copy this and plot it, you will be able to produce the chart, but still you have not leveraged on the data that you extracted. This is manual data. So now we have to replace this manual data with our data. That is what we are going to do. So what we do, we just pass the JSON table, and rest of the code we just keep it as it is. So we are just going to remove the manual data entry and pass the data. Okay, let me run this code again. So it has to be capital I. Okay, where is the second error? Line number 9. Oh, okay. Okay, let me look at the data frame, how it is. Item, okay, there is no S. Okay, still there is an error. Okay, so now I will go back to the LLM. So now I am stuck somewhere, like, okay, so I don't know what is the structure here. Okay, I'm going to run this thing. Okay, it is taking a long time to do. Okay, let us move on. Until this comes, I'll just continue. Okay, so what I wanted to show is, okay, so you can take that program, pass in your manual data, and actually you can create your own charts. Okay, so you can actually do the chart. Okay, so next part what we are going to do is, okay, so now when you're talking about these kind of LLMs, right? Okay, so you have this ChatGPT and you have the Claude, plus you have the other things also. You have a user interface. Like you, that they are not going to show you the path for the file, right? So where initially we found out what is the path of the file, then we change that variable. But what they are asking you to do is you upload a document. So they give you a user interface neatly done like this, like this, like this. So, oh, there is a network error. Okay, so you have this, right? I mean, like you have the upload option. So this user interface is something that will be very beneficial for you. You don't have to go and manually type all these things, right? So that is what we are going to look at in the next part. I think the network error is why it is not able to get the response to us. It is still executing. It's very unusual for us to go like that. Okay, so let me continue. Okay, now I'm going to introduce you something called Streamlet. Okay, so it has shown you. Okay, so let us not worry about what it is doing. Let us continue. Okay, so I'm going to introduce something called Streamlet. So Streamlet is a Python based user interface where you can build your own code and create a front end for you to run this thing. So this front end will give you access to whatever the fields that you want to. So you can upload document, you can upload text, you can upload images, all these things you can do. So now I am going to create this app.py. So this is a magic keyword. So write file app.py, then I import the Streamlit library. So then I do all the other things. So in the user interface, you will need the title. So you will need a description on what you have to do, right? So upload an image as it is displayed below, something like that. So you can do it yourself. Then you have the file uploader. So you can choose what formats that you can accept. Here JPG, JPE, GPG, these are commonly used formats. You can choose that image. Then you can actually get the status, like is it successful in uploading the image. So then based on that uploaded image, you can now pass it to the LLM. So this is the user interface. So where you have you don't have to go and manually change the variable of where you have stored the file, but now you can pass the file through a data upload, similar to what other models do, right? So this is what we create. So generally what happens is this thing, right? Google Colab, it is hosted somewhere. So if you are running your own Jupyter notebook in your local environment, you can spin off a Streamlit app and it will create a local host link for you. So then you can go to that link and you can access that particular Streamlit application. But now this Gemini whatever that I have saved here, it is on a Google Colab notebook which is hosted in a different place. It is not, we don't know the IP address, or we don't know where it is running from, we don't know where it is located, we don't know a lot of things. So if we are going to run a Streamlit application, so we have to port forward, or we have to direct that wherever that network IP address to a particular temporary tunnel, and we have to see. So that is how we have to do using Google Colab. So that is why we are installing a local tunnel and we are passing the app.py to that local host, to that Streamlit application, and we are getting that information. So this piece of code, right, where I have put in here, so that will help you to launch that local tunnel and you can run that particular thing. So what I am doing here is, okay, so when you run this thing, again we are accessing a particular IP address hosted somewhere. Okay, when it is running, it will give you the IP address, right? This only I have to use because I am creating this application, so I have to have a password. So when you run this piece of code, it will give you the password of the local tunnel. Okay, so once you run the Streamlit application and you pass it to the local tunnel, it will give you a URL, something like this, BC reverse. So every time it will keep changing. So this is free to use for us, this local tunnel, that whatever that we are creating. So then if you click on this particular link, okay, now the network is not there, I think. So okay, yeah, it is there. Okay, I pass the password. So this is where you pass in the tunnel password, then you click submit. Okay, tunnel is on. Okay, so let me run the tunnel then. App is there. Okay, so I will run the local. Will it run? It is already executing. Okay, let me stop what it is executing. Okay, so this part I have stopped. I will run a local tunnel. Okay, so then I will again look at the IP address. Okay, so is it the same 34? Okay, doesn't matter, I'll just copy. Okay, now I will serve the local tunnel. So it is asking that it has to install that particular thing. Okay, it did not install. Okay, I will install again. Okay, it has installed. Now I will run the tunnel. Okay, so now you see it has created a new user URL. Okay, I click on this, it will open. So earlier it was BC reverse or something like that. So now it has changed to this. Okay, I pass the password. I click submit. You will be now served whatever that you put in your app.py. So if you have local Jupyter notebook running, you can see this whatever Streamlit application that you develop in your local host with the port number. So here I am serving the port number, right? 8501. So localhost colon 8501, you will be able to see this. So this will take some time, but it will eventually load and give us the user interface. So there you can upload your bills and stuff and things like that, and you can do whatever you want. Okay, so this makes simple for you. You don't have to go sit and code. Now you just have to upload the code and integrate all the pieces of information of code that I have already shown into one pipeline. It will keep storing into your data frame. Okay, then maybe you can have a key saying, okay, when you press that key, it will give you the charts. It will display the charts in your user interface. So every week or every month or whatever the time frame that you are defining, you can generate your own charts and look at your whatever that you have spent, something like that. Okay, so any questions? So with this I will stop. So we are already on time, like 12:30. So we'll stop here. So if you have any questions for me to answer, I can answer. I can take. What I have just shown you is a very basic thing, like creating a user interface, connecting the models, and getting some piece of information and manipulating that information and doing whatever the task that you want to do. That's all. This is one simple pipeline, but it will solve some of the everyday tasks that we want to do. That's all. Correct. Yeah. You can ask that to LLM itself, like what I want to do. You can ask all those things. So that is how you leverage the LLM to reduce your effort. So now if you want to go and search the internet and extract this information, like what are the tools available, how to do, then you will have to spend time, right? Instead I can just go to ChatGPT and ask the question, okay, this is the task that I want to do, what are the tools available and what is the best one. So you just give a comparison study for me, it will give you. Now your time is saved, so you can just look at that. Just note that sometimes it can hallucinate, that's all. But other than that, it's quite okay. And this Gemini API is very like free to use, so you don't have to spend money. So rest of the APIs you have to pay minimum $20. Like students, they will not be able to afford that much money, right? I mean, so they come from all backgrounds, so you cannot expect them to pay and learn something. So the moment you say, okay, so you have to pay for this, they will back down. But Google has opened up this API, and the coding also, the coding platform. So similar to Copilot, they have something. They have also open source that. So you can leverage that to understand and learn codes. So as I told you earlier, right, you can pass in lead code questions and it can solve for you much simpler way. You can learn, or we can use it for whatever the technique that you want to do. Okay, sure, okay. Okay, shall I close this or? Okay. Oh, thanks.